Welcome back, students. Today we will be discussing certain numericals based on universal law of gravitation. So in the previous session we dealt with the law, its derivation, and we have done I think that we have done 2 problems based on universal law. Today we will be discussing certain other problems related to it based on our textual exercises. So for the questions, you may please refer your Science NCERT textbook, page numbers 143 and 144. Okay. So now let us begin. Please take page number 143 of your science textbook, question number 1. Question is, how does the force of gravitation between two objects change when the distance between them is reduced to half? So you need to find the force of gravitation when the distance between those objects is reduced to half. So here in the question it is given that the distance between them d is reduced to half, means d becomes d by 2, half of d. Masses are the same, m1 and m2. You need to find force of gravitation. We know that the formula to find force of gravitation is F is equal to G m1 m2 by d square. In our question, the distance is halved. That means F is equal to G into m1 m2 by, instead of d, it is halved. So it is, let us substitute as d by 2 the whole square. Instead of d, it is reduced to half. So it is d by 2 the whole square. That is F is equal to G m1 m2 by, open the bracket, d by 2 the whole square. So it becomes d square by 2 square is 4. F is equal to G m1 m2 by d square by 4. That is F is equal to G m1 m2. To change this division into multiplication, go for the reciprocal of the denominator. To change this division sign into multiplication sign, we need to take the reciprocal of the denominator. So this reciprocal of d square by 4 is just the ulta, that is 4 by d square. That is F is equal to 4 into G m1 m2 by d square. So this is the formula to find force. So the new force F dash is, when distance is reduced to half, new force will increase 4 times, 4 into the actual force. This is the formula to find the actual force, that is G m1 m2 by d square. When distance become half, the new force will increase 4 times. It becomes 4 into the original force. So that means the new force will increase. When distance decreases, the force will increase. So from this problem, it is clear that when distance decreases, force will increase. Here distance got reduced by half, so that the force increased by 4. So when distance increases, force increases. That is, distance and force are in inverse proportion. Hope it is clear. So in the formula, in the universal law of gravitation, just instead of d, just substitute it as d by 2 and solve it, and we can see that the force got increased by 4 times. Okay. Now moving on to the third question. of page number 143. That is, the question is, what is the magnitude of the gravitational force between the earth and a 1 kilogram object on its surface? Mass of earth is 6 into 10 raised to 24 kilogram and radius of earth is 6.4 into 10 raised to 6 meters. Okay. So, the question is, you need to find the gravitational force between earth and a 1 kilogram object. So, the mass of the second object is given as 1 kilogram. Question is to calculate the gravitational force between earth and an object, and mass of earth is given in the question as 6 into 10 raised to 24 kilogram, and radius of earth, so distance between the earth and the object, that is the radius of the earth, is given as 6.4 into 10 raised to 6 meters. So much is given in the question. You need to calculate the gravitational force. Again, to calculate the gravitational force, equation is F is equal to G m1 m2 by d square. Now substitute the values in the equation. That is, F is equal to value of G, the universal gravitational constant G is 6.7 into 10 raised to minus 11. It is a constant which you need to by heart. So, capital letter G, the universal gravitational constant is 6.7 into 10 raised to minus 11 into mass of the first object, that is our earth. It is given as 6 into 10 raised to 24 into mass of the second object is given in the question as 1 kilogram divided by the distance between the earth and the object, that is the radius of the earth, is given as 6.4 into 10 raised to 6 meters. So, this is the case. If this is the earth, we have an object on the surface of earth. That is the radius of, this is the radius of the earth, that means the distance between the center of the earth and the object is the radius itself. So, this is the case. Now, first solve the number part. 6.7 into 6 into 1 into, now the exponents. 10 raised to minus 11 into 10 raised to 24 divided by it is d square, that is 6.4 into 10 raised to 6 square. Now, F is equal to 6.7 into 6 into 1 into 10 raised to minus 11 into 10 raised to 24 divided by 6.4 into 10 raised to 6 the whole square, means it can be written as 6.4 square into 10 raised to 6 the whole square. Okay. Now, F is equal to 6.7 into 6 into 1 into 10 raised to minus 11 into 10 raised to 24 divided by 6.4 the whole square, means 6.4 into 6.4 into 10 raised to 6 the whole square, that is a raised to m whole raised to n. This is in the form of a raised to m whole raised to n. According to law of exponents, a raised to m whole raised to n is a raised to m into n. This is the law of exponent. So, 10 raised to 6 the whole square is 10 raised to 6 into 2. That is F is equal to 6.7 into 6 into 1 into 10 raised to minus 11 into 10 raised to 24 divided by 6.4 into 6.4 into 10 raised to 6 into 2 is 10 raised to 12. Now solve this exponent part which is there in the numerator. F is equal to 6.7 into 6 into 1. This is in the form of a raised to m into a raised to n. Instead of a we have 10, instead of m we have minus 11 and instead of n we have 24. A raised to m into a raised to n is a raised to m plus n. That is 10 raised to minus 11 into 10 raised to 24 is a raised to m is minus 11 plus n is 24, which is equal to 10 raised to minus 11 plus 24, which is equal to 10 raised to 13. So it becomes 10 raised to 13. So this is the solving part of this, by 6.4 into 6.4 into 10 raised to 12. That is, again solve this exponent part. F is equal to 6.7 into 6 by 6.4 into 6.4. See, a raised to m, it is the form of a raised to m by a raised to n. Instead of a we have 10, instead of m we have 13 and instead of n we have 12. It is a raised to m minus n. The formula is a raised to m minus n. So 10 raised to 13 by 10 raised to 12 is 10 raised to 13 minus 12, which is equal to 10 raised to 1. 10 raised to 1 is 10 itself. So into 10. Okay, we have solved that too. So that means we have solved the exponent part. Now solve this. Multiply and then divide it. On dividing, you will get the answer as 0.98. On simplifying this, you will get the answer as 0.98 into 10, which is equal to 9.8, and the SI unit of force is Newton. So answer is 9.8 Newton. So in order to do the problem, you have to be thorough with the law of exponents. The 3 laws of exponents. The main formula to do the problem is F is equal to G m1 m2 by d square. Substitute the values in the formula. The value of capital letter G is a constant. Now first try to solve the exponent part first. For that you make use of the formula a raised to m whole raised to n is a raised to m into n. Then again you need to make use of the formula a raised to m into a raised to n is a raised to m plus n. Again to solve this part, finally you need to make use of the formula a raised to m by a raised to n is equal to a raised to m minus n, and finally you will be solving the exponent part. Then you can go for the numerical part, multiply, then divide, and you will be getting the answer as 9.8 Newton. So you need to be thorough with the formula of universal law of gravitation plus the law of exponents which you have studied in your mathematics to do the problems based on universal law. Hope it is clear. Now moving on to question number 4 of your textual exercise, that is page number 143. Page number 143, question number 4. The earth and the moon are attracted to each other by gravitational force. Does the earth attract the moon with a force that is greater or smaller, or the same as the force with which the moon attracts the earth? So, we have two objects, moon and earth, and we know that moon exerts a force on earth. In return, earth will also exert a force on moon. The question is, will these forces be equal, or will one force be greater and other force be smaller? We know that according to universal law of gravitation, every body attracts the other body with the same force called gravitational force. That means the force between moon and earth, that is the earth and the moon will exert same force on each other. According to the law of gravitation, every body will attract each other with equal or with same force called gravitational force. So, the force between the earth and the moon will be the same. Okay. Now, moving on to fifth question of the textual exercise. If the moon attracts the earth, why does the earth not move towards the sun? Just now we told that earth will exert a force on moon. At the same time, moon exert a force back onto earth. Then why earth is not moving towards the moon? Okay. Answer is, according to Newton's second law, we know that F is equal to ma. From this equation, let us get an equation for acceleration A. A is F by m. So, if force is constant, acceleration of the body and mass are in inverse proportion. Mass is in the denominator and acceleration is in the numerator, which means mass and acceleration is in inverse proportion. Since one is in the denominator part and the other is in the numerator part, it means that both are in inverse proportion, which means if mass increases, acceleration will decrease, and if mass decreases, acceleration will increase. This is the meaning of inverse proportion. When one quantity increases, the other quantity will decrease, and vice versa. That is the meaning of inverse proportion. So, here the mass of earth is very large compared to mass of moon. Mass of earth is too large compared to mass of moon. So, what about its acceleration? When mass of earth is larger, means acceleration of earth will be since mass of earth is too large, acceleration of earth will be less according to Newton's second law. So, since acceleration is less, even though earth is attracted towards the moon, since acceleration is less, it is negligible and it cannot be seen. So, when mass increases, acceleration decreases and the movement becomes negligible and cannot be seen. That is the answer for fifth question. Now, moving on to the last question of today's session, that is the sixth question of your textual exercise. That is in page number 144. Page 144, question number 6. What happens to the force between two objects if, subdivision 1, the mass of one object is doubled? Subdivision 2, the distance between the object is doubled and tripled. Subdivision 3, the masses of both the objects are doubled. So, you need to find the change that happens to force of gravitation in the 3 cases. So, let us take subdivision 1 first. In subdivision 1, it is said that mass of one of the object is doubled. So, it involves 2 mass objects of mass m1. Second object's mass is doubled. That means m2 becomes 2m2. One of the mass is doubled. So, m1 remains the same. The mass of the second object became doubled, means it became 2m2. Distance of separation is d itself. Now, the formula to find force is F is equal to G m1 m2 by d square. This is the formula to find the force. Now, let us substitute the new values. So, the new force when one of the object is doubled, let it be F dash, let the new force be F dash is equal to G, m1 is same, instead of m2 we have, it is doubled, so we have 2m2 divided by distance of separation is same as d itself. So, F dash is equal to, let us take that 2 outside, so 2 into, just rearranging it. So, it becomes G2 into G m1 m2 by d square. This is our old force. So, new force is 2 into the actual force. So, when one of the mass is doubled, force increases 2 times. When one of the mass is doubled, the new force will increase by 2 times. It is 2 into, which means the force will increase. Okay, force increases by 2 times. Now, moving on to subdivision 2, the distance between the object is doubled and tripled. So, in subdivision 2, we have 2 cases. In the first case, distance is doubled, masses remains the same, distance got doubled, means distance became doubled, means 2d. The formula to find force is F is equal to G m1 m2 by d square. Now, let us find the new force when distance got doubled. So, F dash, let the new force be F dash. So, F dash is G into m1 m2 by, instead of d, it is doubled. So, instead of d, let us substitute 2d the whole square. That is F dash is equal to G into m1 m2 by 2d the whole square is 4d square. That is F dash is equal to 1 by 4 into G m1 m2 by d square. I just rearranged the equation. F dash is equal to 1 by 4 into G m1 m2 by d square. See, G m1 m2 by d square is the old force. So, F dash is 1 by 4 into the original force. So, when distance got doubled, the new force became 1 by 4 times, which means the new force will decrease by how many times? Decrease by 4 times. Since 4 is in the denominator, it means the new force will decrease by 4 times. Since here 4 is in the denominator, it means the new force will decrease by 4 times when distance is doubled. When distance increases, the force will decrease. So, when distance is doubled, the force got decreased by 4 times. Now, what is the case if distance is tripled? Second subdivision itself, case is distance is tripled. Here also masses remains the same, that is m1 and m2. distance got tripled. Triple means it becomes 3D. And we know that the formula to find force is F is equal to G m1 m2 by d square. F is equal to G m1 m2 by d square. Now let us find the new force F dash. F dash is G into m1 m2 by, instead of d it is tripled. So instead of d, let us substitute 3d the whole square. That is equal to G m1 m2 by 3d the whole square is 3 square is 9, 9d square. 3d the whole square is 9d square. Now let us rearrange it. 1 by 9 into G m1 m2 by d square. I just rearranged the equation. Again see, G m1 m2 by d square is our original force. That is new force is 1 by 9 times the original force. Here also 9 is in the denominator part, which means when distance got tripled, the new force decreased by 9 times. Since 9 is in the numerator, it means that the force will decrease. So when distance got increased by thrice the value, the force got decreased by 9 times. Okay. Now moving on to subdivision 3, the masses of both the objects are doubled. So in subdivision 3, both the masses are doubled. So m1 became doubled, means 2m1, and m2 also became 2m2. Both the masses are doubled. Distance is the same, d. So F is G m1 m2 by d square. This is the original force. Now let us see what is a new force when both the masses are doubled. F is equal to G into, instead of m1 it is doubled, so substitute it as 2m1 into mass of the second object is also doubled, so mass of the second object is 2m2 by d square. That is equal to G into 2m1 into m2 is 4m1 m2. 2 into 2, 4m1 m2 by d square. Now let us rearrange the equation. Take 4 outside. Remaining is into G m1 m2 by d square. This is the equation of our original force. F is equal to G m1 m2 by d square. That is, a new force is 4 into the original force. Here the 4 is in the numerator part, which means when masses are doubled, force increased by 4 times. Since 4 is in the numerator part, it means that the force got increased. So when both the masses are doubled, the force got increased by 4 times. Okay. So these are certain problems based on universal law of gravitation. The problem that we have discussed just now is too important. Such questions you can expect for your exams. Hope it is clear. Thank you.